that was just a 40-story building doing cartwheels in the sky, evading capture by the automatic flight termination system police, living its best life before inevitably getting caught and going back to jail. If you want to personify Starship like that, I guess you could. Hello, welcome to a slightly different type of stellar spectacle all about Starship IFT-2. Let's start from the beginning. Starship is the largest and most powerful man-made flying object ever built at 121 meters tall and 7,500 tons of thrust. Thrust is powered by an astounding 33 Raptor engines strapped on the bottom. The goal of this behemoth is to make humans multiplanetary and to get back to the moon and Mars. That's cool and all, but a crazier detail is that this thing can hold 4,600 tons of propellant. We'll get back to that in a little bit. This thing has flown once before. On April 20th, 2023, IFT-1 happened, and it was maybe the most insane thing that I have ever seen. Let's look at the first integrated flight test to see what will be similar and different on the second. Also, the first will illustrate just how absurd Starship is. Alright, leading up to this event on April 20th, we knew it would be something like we had never seen before. We had now seen the rocket that will take us back to the moon and Mars, sitting on the launch pad down in South Texas in Starbase. We knew how ambitious it is, but we also thought of what could go wrong. As said, this thing has 33 engines, which is basically the most ever put on a rocket and lit at one time. So, the comparison to the Soviet N-1 was in the back of our minds leading up to the first integrated flight test. The N-1 was the Soviet Union's mega moon rocket in the space race with the United States. It flew 4 times and none were successful. It even created one of the biggest man-made non-nuclear explosions in human history with only 2,700 tons of propellant. Starship has about 2,000 more tons of propellant. So this could go bad. Alright, we get down to the launch. We're watching the launch pad. Starship is sitting there ready to go. Wait, do you see those big arms on the side of the launch tower? Well, this is how Starship is stacked and destacked on top of the booster. But also, the thing will catch the thing. Starship is a fully reusable launch vehicle, which means it comes back and is reused. These arms will actually catch the 70-meter tall booster and the 50-meter tall flying bullet with fins out of the sky to be restacked and flown again rapidly. This is crazy. Just ask anyone, the future is reusable. Alright, we're back to watching IFT-1. The thing lights its engine and takes off. 3 engines were shut down immediately, so it took off with a measly 30 engines. The margin should allow for this, so we should be able to go on with the mission. It clears the tower, and I don't know what's exploding more, our brains or the engines on the bottom. Orange plumes, random explosions, and astounding sights encompass the next 150 seconds, until front flips. Anyone that played Kerbal Space Program is now getting flashbacks to all the times that their rocket was not aerodynamically stable and started flipping in the upper atmosphere. I can speak from experience.
No! No! No!
That's an issue. It's going again. Yep, it's going again. I didn't even do anything. I wasn't even turning that time.
But as you watch the broadcast, no one seems to be alarmed. Was this supposed to happen? Sure. It's complicated, but Starship was supposed to do something similar to this to separate the ship from the booster during stage separation.
Beginning the flip for stage separation.
To save on complicated systems and weight, it may not look like it, but there's not much holding Starship, the ship, to the booster other than just gravity and compressing forces from the launch. The goal was to flip the 40-story building and let inertial forces fling Starship away as the booster flipped around to start its boost back burn. And at this point, I think we all just took a step back and is like, what in the world are we watching here? The ones that understood how the stage separation worked was then confused when the thing started flipping more than one time and stayed together with the engines blaring full throttle still. Thing starts falling towards the water, which brings up, why hasn't the flight termination system blown up the thing? Flight termination systems on rockets are basically charges in the side that blow it up in case something isn't going very smoothly. And I don't know, the thing's falling towards the water, why isn't it blown it up yet? And we're waiting and waiting, and finally Starship gets caught by the police and experiences a rapid unscheduled disassembly or a RUD. Well, SpaceX's Mega Moon rocket was a failure then, right? No, this was a total success. When testing innovation, innovation will show you that it ain't nothing you've ever seen before, and it will rear its ugly head. And when you're trying to get to Mars, you need new ideas pronto, yesterday, expedited shipping even. And as they say, if you aren't failing, you're not innovating enough. Capturing data, especially on a first flight test, is almost as important as the thing getting to space. That's why when you test at the beginning of these innovative programs, things blow up more than they go right. Just look at SpaceX down in McGregor, Texas. They blow up Raptor engines all the time, pushing the limits and making the Raptor engine better. I mean, shoot, look at the suborbital test hops SpaceX has done with Starship, the ship. SN8, SN9, SN10, SN11 all failed and blew up for different reasons, and SpaceX learned and improved for SN15, which ended up landing successfully. SpaceX said they're gonna do it differently and do it better, and well, that's how you get there. Alright, it's time for the second integrated flight test. You look down at Starbase Texas at Ship 25 and Booster 9 and they are ready to go, and you have to ask yourself, what is going to cause these to not just do a full repetition of the first integrated flight test? And Elon has the answer for you. Over 1,000 improvements. Alright, well, what improvements are there to make? Well, if you watch the video from IFT-1, we gotta start with the launch pad. I mean, just watch. When the power of the 33 Raptor engines are berating the ground for over 7 seconds while it's being held down, chunks of concrete are being sent back to the Shadow Realm all the way to SpaceX's headquarters in California because those things made it all the way to the Gulf of Mexico. Under the launch pad became a crater, and a rock tornado, Elon said, formed while Starship was ascending from the pad. And for IFT-2, this obviously needs to be fixed because you can't destroy the launch pad every time you use it. So let's get into some of the improvements to the pad. Firstly, SpaceX will not hold down Starship for nearly as long, about half as long, as IFT-1, just so the power of the Raptor engines aren't berating the concrete, or, we'll get to it, what's underneath it, for as long. And most obvious when you're watching IFT-2 is SpaceX instituted their own version of a water deluge system, which is basically an upside down shower head, steel plated, that shoots high pressure water underneath the Raptor engines as they ignite. This decreases vibration and force with the ground. And this thing isn't messing around. It shoots so much water that the US Fish and Wildlife Service had to investigate whether it would change the surrounding ground and impact the environment. And earlier this week, they said it was all good for launch. And speaking of regulatory approval, a rocket exploded in the air and the FAA needs SpaceX to improve it so it just doesn't do that. Now on to after launch. Starting with the engine problems, Elon Musk said that Booster 7's shielding around the Raptor engines were not as thorough and high quality as what is on Booster 9. This should allow for better protection of the engines when, I don't know, a fire encompasses the bottom of the engine block and a hydraulic power unit possibly explodes. And those two things I just said also brought improvements, starting with hydraulically powered systems on Starship. Hydraulics are gone for Starship, Booster 9, and future Starships after this. On Booster 7, the engine's TVC, or thrust vector control, or steering the engines, was hydraulically powered. On Booster 9 and future Starships after this, they are electrically powered via electric motors, which eliminates complexity. Alright, fix the hydraulics problem, but there are still fires on the base of Starship. The improvement called for is a better fire suppression system on the base of Starship. And when I mean improvement, I mean the FAA required SpaceX to have 15 times more capacity. Now there are much bigger CO2 tanks on the side of Starship that shoot CO2 right before the engines are lit. As SpaceX says, fires from leaky propellant caused them to lose communications with the engines entirely, which hopefully this fire suppression system will fix. This also means that a 120 meter tall skyscraper was berating out of the sky, engines full going, without control. On to stage separation, which will look completely different than IFT-1. SpaceX is ditching the idea of the crazy catapult that separates the ship from the booster. SpaceX saw that and said, no thank you, we're moving on. Let's just blow the thing away from it. You heard me right. Future SpaceX boosters, including Booster 9, have a 1.8 meter tall section on the top of the booster called the hot stage ring, which also makes the entire ship 1.5 meters taller. And what this hot stage ring does is allows the engines to vent as they are propelling ship away from the booster. So wait, you're telling me that SpaceX's Starship upper stage lights its engines while still attached to the already propelling booster? That's exactly what I'm saying. As Elon puts it, Starship never stops thrusting. I mean, just look at it. SpaceX changed the definition of MECO. In spaceflight, it usually means main engine cutoff, but for Starship, it means most engines cut off, meaning that the booster will go from a hopeful 33 down to 3. Starship will propel away and the booster will flip around to come back to land. Alright, well that will look very different from IFT-1 to IFT-2, but one of the biggest no-nos from IFT-1 is that the ship didn't blow itself up fast enough. The answer to the IFT-1 craziness is that it tried to. Elon Musk said it took over 40 seconds for it to actually blow up after the boom boom button was pressed. And as I say boom boom button, I don't actually mean an actual button someone presses. It's all autonomous on the vehicle. It's not like how it used to be where there's someone literally with a big red button to blow it up if something went wrong. And how the FTS is supposed to work is charges are placed on the side of Starship to blow holes in the tank to create a reaction for it to all blow up. These charges did go off on IFT-1, but Starship decided, those things are weak, I'll stay strong, and continue doing cartwheels in the air while staying together. That's why I say when Starship was being a disobeying child on this part of the flight, it's because it was. And what's the improvement for that? Well, if those charges weren't enough, let's just add more of them. So they added a few charges to the side of Starship, and it should work. They tested this over the past couple months down at Starbase. And well, we just went through a few changes, but thousands were instituted. That's why IFT-2 will probably not look quite like IFT-1. Alright, the mission profile for this is that Starship will take off, stage separation will hopefully happen, the booster will come back and land in the Gulf of Mexico, and the ship will almost do a full orbit around the Earth to land in the ocean right next to the coast of Hawaii. And obviously, like I said earlier, this is still a very experimental rocket, very ambitious. Things that we don't even think could go wrong could and probably will go wrong. We'll just have to see what hand Murphy gives us this time. You best believe I'm gonna wake up early on launch day to watch this thing cruise into the sky and our next step to becoming multiplanetary. All I gotta say is Godspeed SpaceX, Godspeed Starship, and I'll see you next time.